Hello everyone, welcome to my video again. This is my third video of the series of mathematics, core mathematics related to APDCL, WM, and ACCL, WAPS. So this could be a video regarding calculus, and I will try to provide my best for the important questions that can be arises from calculus. So let's begin the video and stay tuned, and please try to focus on the concept instead of the straightforward reasonings. Always focus on the concept. So let's get started. Go to the next slide. Yeah, here the question is that we have the question that if f is strictly increasing on domain, which is a set of real numbers, then it arises questions about the existence of its inverse and how it behaves. It is decreasing or increasing. It mainly focuses on the inverse of the function f inverse. Okay, and its behavior. What is it is behave? So you all know that that fx is strictly, that means f dash greater than 0. But if f is only increasing, it implies f dash greater than or equal to 0. It is a little bit of difference in it there. So we'll try to assume the fx, given fx, which is strictly increasing. So for our easiness, or you can say that for our convenience, we'll try to assume fx value. So here the fx is x, the exponential function, which is basically an increasing function. We all know that but the interval is most important thing. Domain 0 to infinity, which is a subset of real number. So it is increasing, exponentially increasing. The function is exponentially increasing in between 0 to infinite interval. So we'll take that fx, and what is its inverse? We all know that its inverse is log x. Okay, so log x has the behavior. We all know that log x has to be if we take y equal to x, this line, we always find out the inverse of any functions. Okay, so we'll have the inverse of e to the power x, which is log x. Yes, the same behavior. We all know the replication of e to the power x is log x. It is directly inverse of that function, so which is also an increasing function. So what we have in the questions? So we have in the questions that it is decreasing. No, it is not decreasing. It is strictly increasing on the. So what will be the answer? Option B is the correct answer. So go to the next question. Okay, so next question is fx dot fy, means it is a homomorphism. It is a homomorphism from set, you can say, real number to real number, which is where is a phi x plus y equal to phi x phi y. This is actually homomorphism. So what we have given f3 equal to 3, f dash equal to 11, and f double dash equal to 6. What is it will have value. So this is the question. So we'll have check. So go to the next slide. What could be the final approach? What is the right approach? What can be the another approach? So we'll have check on Pemanek again. So go to the next slide. So yeah, given that f the 0 equal to 11, what is it is given? So by the definition of differentiability or differentiable functions, we already know that fh minus f0 divided by h. This is the primary or basic definition of differentiable functions. So we can write it down there. Again, the value of f0 can be deducted from by putting x equal to 0 and y equal to 0 in the given function. So putting that, we will get the value of f0 equal to 1. So by putting that value in that equation, so we'll get this term. So after that, what we have to evaluate is the f dash 3. So by definition, we always try to follow the definition, basic definition. So fh plus 3 plus minus f3 divided by h, h tends to 0. By again that definition of the function, that fx plus y equal to fx dot fy, that definition follows. Taking out f3 here and multiplying, this is the it is very basic question. So by that, we'll get f plus 3 equal to 33. Very straightforward question. Go to the next question. What is f3? Oh, sorry, question number 3. If fx is real value, function defined on 0 to infinity functions that f0 and f double x greater than 0 for all x, then gx equal to fx divided by 3x, which can be the attaining values, or it is decreasing, increasing. Foremost, it is asking about the behavior of that function gx. So let's see what can be the approach. Given here is fx is real valued function and the domain is 0 to infinity, f0 equal to 0, f double dash equals greater than 0. So go to the next page. So we have to evaluate them, investigate the behavior of the gx function primarily. Okay, so go to the next slide. It has if f0 equal to 0 and f double x greater than 0, it is given here. So z dash x equal to, this is what we have got from what we have learned in our basic differentiability, is that this is the thing, the formula we already learned. This is the formula that we have here. So by putting all these values and by cutting 3 or taking out the 3, and this is the term that we have get. So again, let this term equating with taking it as hs and differentiating here. So what we have got, this term greater than 0, because f double dash greater than 0 and x greater than 0 for all. It is given. These things are given in the question. So it is primarily this term is greater than 0. It is obviously it is c greater than 0, because 3 greater than 0, x greater than 0. So it is greater than 0, which implies that gx is what? Gx is increasing. So this is the answer. Gx is increasing. So go to the next slide. What is the next question? And the next question is if fx and gx are two differentiable functions on open interval a comma b and are continuous on closed interval a comma b, and f equal to 0 and f equal to 0, then there exists c belongs to a b such that these are the options. So what can be the approach? Let's see that. So we have to take the functions like this way, because here again we have considering this function in our easy convenient way, so that we can use the Rolle's theorem on that function. So we have taken it as fx product e to the power gx for all x belongs to a comma b. But fx is differentiable on a comma b. It is given because fx and gx are multiplications. Any functions f and g, if multiplied and both are individually differentiable, then multiplication also differentiable. So by taking that property of functions or we can evaluate fx is differentiable and fx is continuous on a comma b. So it is on in open interval and it is on closed interval. So f equal to fb. So by satisfying all these properties of Rolle's theorem and taking the final result of Rolle's theorem, what Rolle's theorem says is that there exists always an a point x belongs to that interval a b such that f dash x equal to it always having at least at a point which derivative is 0. So taking that point again, that taking that point as c, then we'll also have f dash c equal to 0. So by taking f dash x by n x equal to c, putting that value, we get this term, this term, this term. So by since e to the power gc, which cannot be that taken as value 0, so definitely it will have this kind of relation. So this kind of relation is the option A is the correct answer. So let's go to the next question. What is F? Question 5. F from close double 0 to 0 10 of the continuous function. So obvious continuous function it is given. So it has at least one fixed point, at least one at most one fixed, at least these are the keywords, at least, at most, and at least. So this is a replication of identity theorem. So next slide. Okay. It is the application of identity theorem. Because by identity theorem, there exists at least one fixed point c belongs to 0 1 such that fc equal to 0. It is mentioning the word at least. It is direct replication of identity theorem. So it will at least fix one fixed point. This is the right answer. What is the value of alpha in Rolle's theorem, where alpha in between minus pi by 2 and pi by 2 and fx equal to cos x is equal to what is the value of alpha we actually evaluate. So yeah, again, by taking Rolle's theorem, what Rolle's theorem says that always there exists c belongs to that interval, that the given interval a b such that fx belongs to that f dash x equal to 0. So cos x, differentiation of cos x is minus sin x, and because in between the value of minus by 2 and pi by 2, sin x only can take value 0 when x equal to 0. This is the diagram or graph I have shown here for your easiness. So last question, that is question number 7. If fx, here it is the question option number D is the correct answer for question number 6. So what is the question number 7? If fx given is that this value, this term, so is an increasing function in the interval. It is depicting that it is increasing. That means tax x greater than or equal to 0. Because it is stating that it is increasing, so it is greater than or equal to 0. Not greater than 0. Not mentioning that it is straightly increasing. This depicting that only increasing function in that interval. So going to that next slide. So yeah, by taking the differentiation, we'll get that. And taking value of minus 6 here, minus 6 we'll take out the value -6 from there, and multiplicating minus the sign also revert, and by taking factorizing the quadratic equation, quadratic inequality, we'll get this term, and by this method we'll always find the domain, or we can say the domain of the roots. So how it values lies. So it lies in between -2 and -1. So this is a very straightforward and easy equation. Um, yeah, this is the correct answer. So these are the questions that are very important from the exam perspective regarding calculus. So yeah, thanks for watching, and keep supporting and keep watching my videos. This will definitely help you in this examination and further any examination that related to higher mathematics. So thank you for watching. Signing off. Kulinda. Bye bye.